Hey, what's up, Logaristas? It's time to stop having fun, start to get some work done. First order of the day, we need to graph these three functions. X squared, which we've done before, 2 times x squared, and negative 2 times x squared. Let's get going. All right, so we're going to make a t-chart, as always. We're going to have x, our inputs, and our outputs, f of x, g of x, and h of x. For the inputs, I'm going to do the numbers from negative 3 to positive 3. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, f of x is x squared. Negative 3 squared, negative 3 times negative 3, positive 9. Negative 2, remember this is in parentheses squared, so negative 2 times negative 2, positive 4. Negative 1 times negative 1, positive 1. 0 times 0 is 0. And this bottom half will be the same as the top part, but in reverse order. Right? 1 squared is 1, 2 squared is 4, and 3 squared is 9. That takes care of f of x. Now what about g of x? Well, that's just 2 times x squared. So that's 2 times f of x. So all we need to do is take this column and multiply it by 2. So 9 times 2, positive 18. 4 times 2, positive 8. 1 times 2, positive 2. 0 times 2 is 0. 1 times 2 is 2. 8, 18. So this column is just this whole column times 2. Makes sense? Finally, h of x. Well, that's negative 2x squared. And 2x squared was the same thing as g of x. So this is the negative of g of x, which we just did. So this column is the negative of this column. So all we do is take all those numbers and we flip the sign. Negative 0 is the same as 0. And all the rest are pretty simple. All right, on to graphing. I'm going to draw my xy coordinate system. And we really only care about the values between negative 3 and 3. All right, time to graph this thing. Remember, we're graphing pairs, x comma y. So the first point on the graph of f of x is negative 3 comma positive 9. Left 3, up 9. That's about here. Second one is negative 2, positive 4. Left 2, up 4. I'd say that's about there. Third one, negative 1, positive 1. Left 1, up 1. 0, 0, that's our favorite, that's the origin. 1, 1, that's right 1, and then up 1. 2, 4, right 2, up 4. And 3, 9. Right 3, up 9. Okay, so this is f of x. We can connect the dots to make a smooth curve. And we get something like this. Now this shape is known as a parabola. And that's the graph of x squared. Now let's see how the graphs of these other two compare. So we want to plot points on g of x. So we do x comma y, where the x comes from the first column as always, and the y's come from this g of x column. So -3, positive 18, that's way up there, so I'm not going to put that there. -2, positive 8, that's left 2, up 8. -1, positive 2, that's left 1, up 2. 0, 0, that's our origin again. 1, comma 2 is right 1, up 2. 2, comma 8. I guess I drew these sort of out of alignment. Let me rewrite that. This should be that row here. Okay, I think you got the idea. Anyway, 2, comma 8, right 2, up 8. And 3, comma 18, well, that's off the chart again. Okay, so we can connect this to form a nice smooth curve. Okay, so this is the same general shape as x squared, so it's also a parabola. But how does it relate? Well, each of these y values was twice the corresponding y value for f of x. So this is a stretch by a factor of 2 along the vertical axis. So let's put this somewhere. I'll put it here. This is a vertical stretch by a factor of 2, so times 2 of f of x. Because we took each of these y values and we multiplied them by 2. We stretch this thing, and you get this curve g of x. Well, that makes sense. What about h of x? Let's do the same thing. -3, -18, left 3, down 18. It's off the charts. -2, -8. That's left 2, down 8. -1, -2. That's left 1, down 2. 0, 0. We already know that's our origin. 1, -2. So again, these are all out of alignment. That's my fault. Rewrite this so this was -8. Anyway, 1, -2. That's right 1, down 2. 2, -8. That's right 2, down 8. Right from there. And +3, -18. That's off the charts again. So we connect this to form a smooth curve. And you might have already guessed that this is simply a reflection over the x-axis of this purple, magenta, whatever it is, curve g of x. So reflection of g of x, whoops, not f of x, over the x-axis. And the reason that it's a reflection is that this is just -1 times g of x. So all these y values become their negatives. So it just flips everything over. And of course, in relation to the original f of x, this is a vertical stretch times 2, and then a reflection over the x-axis. Makes sense.